Assalamu alaikum students. How are you all? I hope you all are very fine. Welcome in the world of physics. As you know, we are on the chapter number 5 and that is all about the gravitation. So we will discuss another topic of this chapter today. As in last video based lecture you have seen first two main concept of this chapter. Today we will discuss the third major concept of this chapter. You already know the universal law of gravitation, and you have observed this thing that if you are away from the surface of earth, away from the earth, you feel less gravity of the earth. So actually today we will discuss that how the value of gravitational acceleration will varies with the altitude height from above the sea level. Topic is 5.3 variation of g with altitude. This is on the page number 110 and 111. Students, you already know the concept of gravitation. You already know the force of gravity. You already know the gravitational field and the gravitational field strength. All these things are now very clear to you. So let's you have an object, and that object at the surface of earth. Then you can say that you finally concluded that if the mass m is on the surface of earth, the distance between small m and the capital M for the mass of earth, so the distance between these two objects will equal to the radius of earth. What I said if the small m is on the surface of earth, the force of gravity between small m and the earth will be equal to weight of the small object. What I said, mg is the weight of this red object, and this thing is the force of gravity, gravitational force. So m is going to be cancelled out with the m. So final result with the gravitational acceleration will become as capital G capital M over r square. Capital G is constant, capital M is already constant. You had seen in 5.2 mass of earth was the 6.24 into 10 raised to power 24. So for this small m, if it is at the surface of earth, the gravitational acceleration will equal to capital G capital M over r square, distance between these two masses. Okay, what about if your object, if your mass is not at the surface of earth? You are going to say that your object is not at the p point here, the object is at some height, and like say that object is at q point. You now can see that the distance is going to be increases between these two objects. The distance between small m and the capital M mass of earth is increases. Then you are going to observe that the distance is equal to capital R plus h. Why? Because object is not at the surface of earth, object is at some altitude. Altitude means the height above from the sea level. Now what happened with the gravitational acceleration? Of course you will observe that the gravitational acceleration will become decreases or will be lesser as compared to the gravitational acceleration at the surface. So at that point, at that height, at that altitude, I am going to say the gravitational acceleration as small g h, gravitational acceleration at that height. Let's discuss it. Let's how to find out the formula for the gravitational acceleration at that height, at that altitude. Your object, your mass is not at the surface of earth, it is very clear to you. It is at the altitude, it is at some height, that is small h. So the weight here, the weight of the object will equal to gravitational force. You already know the gravitational force will be equal to the weight of the object. This object will experience the gravitational force equal to its weight. So I'm going to say mgh is equal to gravitational force. Here you can see capital G capital M small m. masses m1 m2 is here, capital M, capital M and small m. The distance is here not equal to r square. The distance is here r plus its whole square. Why? Because now the object is not at the surface of earth. The object is at some height, and you know that we have to take the distance from the center of earth. So from the center of earth to the surface of earth, the distance is capital R, and from the surface of earth to next to center of object, the distance is small h. So I'm going to say r plus h whole square. After solving it, I'm going to conclude that small g is equal to capital G capital M over r plus h whole square. This is the final formula for the gravitational acceleration at the altitude at some height. Next, go to understand it more briefly. The thing is variation of g with altitude. The question like here, explain how the value of g varies with altitude. Means you want to understand the variation of g with the altitude. So what we have to do, small g is equal to capital G capital M over r square. You already know that capital G is the gravitational constant and capital Me is the mass of earth. These two things are constant. So small g is only going to be vary with the r square. You can say that small g is inversely proportional to r square. What I said both are inversely related to each other. R square is actually the distance from the center of earth. So g is going to vary with the r square. Why? Because capital G is gravitational constant. Its value is not going to be changed ever. Mass of earth is not going to be changed ever. It will remain same. So only g depends on the distance, on the altitude. Okay, if you you already know the inverse relation, means one thing is going to be increased, the other thing will going to be decreases. I hope you are very clear to this thing. Okay, if your object is at some height, then your formula will become like as here you can see. Your formula will become with the variation of height with the variation of distance from the center of earth. You are going to write it as small g is equal to capital G capital Me. These two things are constant. You are not going to change these two things. Simple one thing is going to be changed here, and that is distance. The distance will become r plus h. So I am going to write the gravitational acceleration as small gh is equal to capital G capital Me mass of earth over r plus h whole square. Why I am going to write it r plus h here? Because now the object is not at the surface of earth, it is at some height, and that height is h. So the distance between the center of earth to that object is r plus h. I hope you are now very clear to this thing. Okay, what happened to the value of gravitational acceleration if you are at the height equal to the 1 earth radius? But what I said actually, I am saying like if your object is at the height and that height is equal to 6400 kilometer from the surface of earth, means from the surface of earth your object is at more at some height, and that height is equal to 1 earth radius. Then your formula will become, you are going to put the value of h, and that will be r plus r, and after that you are going to take square, and it will become 4r square. So 1 over 4th remaining this thing is the gravitational acceleration at the surface of earth. So what can I say? I can say like the gravitational acceleration at the altitude equal to 1 earth radius will become 1/4 of its value on the surface of earth. Means that small g at that height will decreases. How much? 1/4. 1/4. You already know the small g at the surface of earth is 10. So 10 by 4 will be the value. Okay, another condition. What is the value of g at height equal to 2-earth radius. Means now your object is equal. Now your object is at some height, and that height is equal to 2-earth radius. What I said, this edge is actually from the surface of Earth. From the surface of Earth, the object is more at 2r. So go to put the value of edge. That will become 2r plus r, 3r square. 3r square will equal to 9r square. So your new value becomes 1/9 of the gravitational acceleration at the surface of Earth. Means 10/9 will be the result. Capital G, capital ME over r square. This thing is the gravitational acceleration at the surface of Earth. So your new gravitational acceleration at that height will become 1/9 of the gravitational acceleration at the surface of Earth. So 10/9. I hope you can understand it very clearly, that there are simple two conditions. If you can go to understand that what we have to be do simple bit here. You can see I said, if this is the mass of, this is the Earth, capital with the capital mass M, your object, if your object is at height and that height is equal to r, means 6400 kilometer from the surface of Earth, you can't change the radius of Earth. So what I finally said, that gh will become equal to 1/4 of g. And if h is equal to, if you are going to say that your object is at more height, and that height is equal to, h is equal to 2r, means your object is at height and that height is equal to 2 earth radius. So your finally result will be gh is equal to 1/9 of the gravitational acceleration at the surface of Earth. I hope these things are very clear to you. Go to learn this topic, go to observe these things in your daily life, and finally you can easily do all the numericals, all the problems with the final formula, with the final result. And this that is small gh is equal to capital G capital M over r plus h whole square. Thank you so much. Allah Hafiz.